In lesson 6.1, we're going to look at some statistics, specifically looking at mean, median, mode, and range. Statistics is the study of gathering, organizing, and interpreting numerical information. This information comes in the form of data, which are values measuring some characteristic of interest, such as weight, cost, time, etc. This collection of data can represent the entire population of items or just a sample or part of the population. Data is typically represented as a set, which is a list or collection of values or numbers that can contain repeated values. Statistics is important in the quality control process for business, in the analysis of data in the sciences, and the communication of research results. And many of you are probably going to take statistics class after 058. So one of the first things that looking at statistics is looking at the range of the data, which is the difference between the largest and the smallest data item. So some people call this the spread of the data. The range of the data shows how close together or how spread apart the data points in the data set are. The smaller the range, the closer the data points are grouped together. The larger the range, the more data points are spread apart. So it asks us to find the data range of the data sets. And we have 3 different sets we're looking at. And when we're doing this, remember, we're looking at the difference between the largest and the smallest. So don't forget that you have to look for those things. So when we look at our first data sets, you can see that the largest number that we have is 12. And the smallest number that we have is 1. So the range for our first set of data would be 11. In part B, the smallest I see is 2 and the largest is 5. So we need to do 5 subtract 2. And that will give us a range of 3. And then finally, for our range of the data set in part C, the largest number that I see is 32, and the smallest is 1. So we have 32 subtract 1 to get a range of 31. So the data set where the points are closest together would be set B. The smallest being 2 and the largest 5 only gives us a spread of 3 there. The data set that has the furthest apart numbers would be set C, where we have 31 as our range. So now we're looking at measures of center. The mean of the data set is the sum of all the data divided by the number of data items. And so many of you have referred to that before as finding the average. Add them all up and divide by how many there are. The median of the data set is the middle data item, or the average of the 2 middle data items when all the data is ordered from least to greatest. So when you have a set of numbers, if it's an odd number of things, like you have 7 numbers, then you will have 1 number that's in the middle, and that will be your median. If you have an even number of data items, you'll need 2 in the middle. So, for example, if you have 10, you would have 5 on one side and 5 on the other. So what's in between those 2, or the average of the middle 2, adding them up and dividing by 2 will give you that median number. So sometimes The number is part of your data set, sometimes it is not. And then the mode of the data set is which item appears the greatest number of times. So for mean, it's the average. Think the average person is not mean. The median is in the middle. Think of that median when you're driving as being what's in between your driving and the oncoming traffic driving. And for mode, MO for mode, and MO for most often. That's how I remember. MO. When you're looking at this data, it's important to order your data from least to greatest when you're finding that median, because if you're trying to find that middle number, it's impossible to do unless the numbers are put in order. And then again, as I've already mentioned, if there's an odd number, the median is one of the data points in the middle, but if there's an even number, you have to take the average or the mean of the two items that are in the middle. So let's look at our median. Find the median of this data set, 6, 1, 3, 4, 7. So there's 5 numbers there, so we will have a number from our set that's in the median. But again, our first order of business is to put them from smallest to largest. So we have 1, 3, 4, 6, and 7. And so when we look at them, we have 5 numbers. So in the middle is going to be that third number. And so our median is going to be 4. Now, if we look at the next set, putting it smallest to largest, we would have 1, 3, 7, and 11. So notice since there's 4, we have 2 of them in the middle. And so our median is going to be halfway in between the 3 and the 7. So to find that, we'll do 3 plus 7 and divide it by 2 since there's 2 numbers, averaging them together or finding the mean. So that gives us 10 divided by 2, which is 5. So again, in our first set of data, 4 was one of the numbers in the list. And for our second set of data, 5 is not in the list, but it's a number that's halfway between 3 and 7. So true or false, the median of the data set is always a number in the set? No. It is sometimes. And then how do the medians found in parts A and B compare to the middle number of the range of each data set? It says note to find the middle number of the range of the data set. Find the mean of the smallest and the largest. Okay. So if we look at our set A, which we wrote in red, we would have 1 plus 7 divided by 2. We're averaging the largest and the smallest, so that would give us 8 divided by 2, which gives us 4. Well, that's what we got that time. But let's see what happens when we do set B. We have 1 plus 11, and then divide by 2 numbers. That will give us 12 divided by 2, which equals 6. So it's not the same as the median that we found last time. So sometimes it's the same and sometimes it is not. And then it says, when you are told that the median is a measure of center, what do you think this means? Well, you're saying, I don't know. But when we think of it is a measure of center number-wise, which means the amount of the numbers, not amounts-wise. So again, it's just kind of a way of looking at the data and getting a general idea of what's happening within your data set. So the median is in the center as far as the numbers go, not necessarily amounts from the spread largest to smallest. But again, it gives you just part of a picture of looking at the data and way of talking about it. Now let's look at finding the mode, again, most often. It's also very helpful to organize the data from smallest to largest, and then you just look to see which data item appears the greatest number of times. If all data items appear the same number of times, then there is no mode. And if there isn't a mode, make sure you write none on your paper. For a quiz or a test, don't just leave it blank. So here we have a couple examples. And if we look at this data set here, we have 2, 2, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I like to count to make sure I got them all. Sometimes I'll mark them off as I'm going if I get confused. But we see that the number 2 appears twice in our data sets. And for our second set of numbers, we have a 2, 2 3s, 3 5s, a 7, and a 9. Okay, let me check. 3, 4, 5, 6, 7, 8, 3, 6. Okay, I've got them all. So as you can see now, we have 2 that are 3s, but 3 that are 5s. And so 5 is the mode. Even though neither one of these cases show that you can have more than one mode, let's say if we had another 3 where there are 3 3s and 3 5s, your modes would be 3 and 5. So true or false? If a data set has a mode, then the mode is always a number in the data set. Well, we're looking at repeated values, so yes, it has to be in the set itself. Otherwise, how can it repeat? And it says, compare the modes found in parts A and B to the middle numbers of the range of the data set. And again, note to find the middle of the range, find the mean of the smallest and the largest. And so if we're going to do that, for our first set, we would have 2 plus 7 divided by 2, which would give us 9 halves, or 4.54 and a half. And then if we were to do that for the second one, we have 9 plus 2 divided by 2, which would give us 11 halves, or 5.5, which neither one of those match. So again, it's trying to have us think of this idea of the measure of center as being more than one option. And so we're not necessarily looking for a specific number, but more of an overall picture, an overall trend or idea. So we can see that the mode has nothing to do with the middle number. And so as far as a measure of center, it is that it is a tendency. It's an attempt to describe identifying information or characteristics of the data set. And again, up here, mode has nothing to do with the middle number. Okay. So now let's look at the data and do all of these different things. Find the range, the mean, the median, and the mode. So first step again is to put your information smallest to largest. And so we will have 5, 7, 7, 8, 9, 10, 11, 12, 13, and we have an 18. Did I get them all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, got them all. Okay, so the range is our largest subtract smallest. See how our spread is, which we get 13 when we do 18 minus 5. The mean is the average. We're adding them all up. And we put that over our 10. So it'll probably be quicker for me to type it than trying and write those. So we have 5 plus 7 plus 7 plus 8 plus 9 plus 10, 11, 12, 13, and 18. And all of that gets divided by 10 because there are 10 numbers. When we add all of those up, we get 100, which makes our dividing easy. So our mean, our average is 10. And then the median is halfway in between. And so if we count off, we're going to have 2 in the middle, which would be the 5th and the 6th number. So 1, 2, 3, 4, 5, 6. So that's going to be the 9 and the 10 in the middle spot. And again, we're dividing by 2 since there's 2 numbers. So 19 divided by 2, and we can leave it as 19/2, but I like to see it as a decimal, 9.5. And then the mode, the only number that repeats itself is the number 7. So MO mode, MO most often gives us 7. Now it's asking us to do a visual representation of our numbers, and it says to plot the data items for the set along with those mean, median, mode on the number line. And so let's go ahead and put our dots on here. We had a 5 and we had a 7 twice. So let me just put 2 dots there. We have an 8, a 9, a 10, 11, 12, 13, and then we skip up to 18. So there's my data points from the set. We have the mode here being at 7. We had a mean or an average of 10. And then we have to add a dot at 9.5, which would be our middle or our median. So there's just a visual representation of those numbers together. In calculating a typical mean, you find the sum of all the values in the data set and divide by the number of values or the data items you have. In this case, all data items are equally important and carry the same weight. In some situations, certain data items have more weight than others. A common example of weighted means occurs when the instructors assign grades. Typically, quizzes and tests will carry more weight in determining your grade than homework or classwork does. And so you'll see, for example, in one of your classes that maybe your tests and your final exam are worth 60% of your total grade. And that is common to see for those. So in order to find what's called a weighted mean, you need to change the weights for each category from a percent to a decimal, multiply the data item in that category by the percents, and then add up those answers together. And then it says divide the sum from step 3 by the total sum of the weights in decimal form. Well, if they add up to 100%, you're dividing by 1 because 100% in decimal is 1. Says compare the typical mean scores from chapter 1 with the weighted mean of the scores from chapter 1. Which mean do you think is a better? Oh, that skipped part of the question. There we go. Suppose your instructor handed out a syllabus with the following grade distribution. Exams are worth 40%, quizzes 30%, homework 15%, and classwork 15%. After chapter 1, you have the following scores: 82 on the exam, 89 on the quiz, 96 on your homework, and 97 on your classwork. So we're supposed to fill in the table with the numbers and round to the nearest tenth if necessary. So let's look at our exams first. It says exams are worth 40%. So 0.40 for the weight. Quizzes are 30%, so 0.30. Homework and classwork are each worth 15%. And if we add all that up, that's 100%, which as a decimal is 1. For the chapter scores, we see an 82 on the exam. So let's fill that in the chart. 89 on the quiz, 96 on the homework, and 97 on the classwork. And so if we add all those up together, we get 364. And now our weighted score, notice it's the weight multiplied by the score. So 0.40 times 82 will give us 32.8. Quizzes is 30%, so 0.30 times 89 will give us 26.7. Homework, 15%, so 0.15 times 96. That will give us a 14.4. Remember, it told us to round one decimal place to 10th. And then 15% of 97 will give us, oh, sorry, that was 14.4, and I wrote 0.6 because classwork is 14.6. And if we all add all of those together for the weighted scores, we see that it's 88.5. So the weighted mean gives us 88.5. Remember, we're supposed to divide that from the total of the weight, which is divided by 1, and anything divided by 1 stays the same. That's where that comes from. But anyway, again, since we're always dealing with 100%, you can just ignore that dividing by 1. And so the weighted mean is 88.5%. So it says find the typical mean as if each grade item has the same weight. And so we have 364 total points. And that was 4 items, 1 exam, 1 quiz, 1 homework, and 1 classwork. And so if we calculate that, we get a 91%. And it says, compare the typical mean scores from chapter 1 with the weighted mean scores of the chapter. Which mean do you think is a better representation of a student's level of understanding? Explain why you chose this mean. Well, that's an opinion. And you might say that the typical mean, because some students may not be good test takers. That might be your stance. Or you might say that the weighted mean is better because of classwork and homework have help. So quizzes and tests show what the student actually knows, more so than classwork or homework would have. So that's just 2 possible answers that you might have and the reason behind them. Now here's your chance to practice finding the mean, median, mode, and range of each data set. Notice number 8 has decimals in there for you to work with. And so when you're working with these, again, don't forget to make sure you put the numbers in ascending order from smallest to largest before you start calculating things. It makes it so much easier for you to do. And then when you're finished with that, you can check your answers and then continue on with the video, and we'll look at some story problems. A math class performed an experiment with fun-sized packs of M&Ms. One step of the experiment was to determine how many blue M&Ms each student had in their pack. One group of students came up with a data set 5, 1, 4, 3, 1, 2, 1, 3, 4, 2. Find the mean, median, mode, and range for the given data set. Round to the nearest tenth if necessary. So let's see here. We have 1, 2, 3 ones, 2 twos, like 2 threes, 2 fours, and 1 5. So check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 numbers, so I got them all. And so for this, we need to do the mean. And again, we're going to add all of those up and divide by 10. So we'll have 1 plus 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4 plus 5. And then we're going to take that and divide that answer by 10. And if we add all those numbers up, we get 26. Divide by 10. And so we get 2.6 for the mean. The median, since there's 10 numbers, remember half would be 5. So that's 5 on each side. So we need to look at the 5th and 6th number and average those two together. 1, 2, 3, 4, 5, 6. So the 5th and the 6th number is 2 and 3. So we'll do 2 plus 3 and divide that by 2 to find the average, which will be 5 divided by 2, which will give us 2.5. The mode is the most often. And so the number 1 was most often. It occurred 3 times, where some of the others only occurred twice, and the 5 only once. And then we need to do the range. Remember, range is the spread, which is the largest minus smallest. So we had 5 minus 1 to get a range of 4. So how do these 3 measures of center compare to each other? And so however you want to describe that, I would say that the mean and median are very close, are very similar. And then the mode is smaller. And then it says, based on this analysis, how many M&Ms would you expect to get in each pack? And so if we're looking at the blue M&Ms, the mode is 1. But since the mean and the median are both in the 2s, I would say that I would expect to get 2. Even though the mode is only 1, again, because the mean and the median are a little bit higher, I would go with the 2. Okay, here we have the final grades for a student during a summer session of math class are given. Find the mean, median, mode, and range for this one. So again, our first step is to put them in order. So we have 60. Oh, let me just type it instead of writing it. It'll be a lot easier to read. So we have 60 and 75, 91, 92, 95, 96 occurs 3 times, and 97, 98, and 100. So there's our numbers from smallest to biggest. So our mean we're going to add them all up. And if we add all of those up, we are going to get 996. I'm not going to spend the time writing that all out because you're just typing them in the calculator. There are 11 numbers. And so that gives us a 90.5 as our mean. Our median since there's 11 numbers, we are going to use one of the data points. And so for 11, there's going to be 5 on either side. So it's going to be that 6th number that we need, which is going to give us a 96. And then the mode, our most often, is the same because that one appears 3 times in our list. And then we want our range as well. Well, we have one perfect score of 100 and a not so hot score of 60 to give us a range of 40. And so how do these 3 measures of central tendency compare to each other? Well, again, in this case, the median and the mode are the same. And our mean or our average is smaller. So based on this analysis, what numerical grade would you expect a student to earn? Well, the mean and the mode are 96, which is A, or the median in the mode. The mean right now is 90.5, which is an A. So I would expect the student to continue on with those higher scores and earn an A for the class. The final grades for an economics class are based on homework, quizzes, and exam scores. The homework counts as 20% of the final grade, quizzes 30%, and the exams count for 50%. By midterm, a student has the following averages: 75% on the homework, 95% on the quizzes, and 75% on the exams. And it's asking us to calculate the weighted mean. So remember, we have to multiply the percent times the number and then add those answers up. And so for homework, it says it's 20% of the grade, and the homework was 75. And so that gives us 19 towards the final grade in the class. Then we have quizzes, which are 30% of the grade. So we're going to do 0.30. And the quizzes were so far 95. And so we multiply that. We get 22.5. And then the exams are worth 50%, so 0.50. And the exam was a 75. And so if we multiply 0.5 times 75, we get 37.5. So when we add all of those up, 19 plus 22.5 plus 37.5. Remember, technically we're dividing by 1 because 20%, 30%, 50%, add up to 100%, as the decimal is 1. We get an oh, I have a mistake here. I was looking at the wrong answer. Hopefully you were doing the calculations and not just relying on me. But we have 15 there. And 28.5 for our quizzes. And 37.5 was right for our exams. I was looking at Part B when I was copying those numbers. I apologize. And so if we add 15 plus 28.5 plus 37.5, we get an 81 for the weighted mean for that. But Part B says another student has the following averages. Homework is 95, quizzes are 75, and exams are 75. So the same numbers, but shown in different categories. So let me see if I can type this to make it a little bit neater. And so for the homework, we have, again, 20% of the grade, but their homework was a 95, which gives the weighted mean total there of 19. Then our quizzes score are 30% of the grade times 75, and that gives us the 22.5 that I had written earlier, and the exam is worth 50% of the grade, so 0.50, and it's the same as the other student, 75, and so we already know that should be 37.5. So for the weighted mean, we have 19 plus 22.5 plus 37.5 to get a total of 79. So the weighted mean for this student is 79. And then another student has the exam as a 95 and the homework and the quizzes as a 75. So let's calculate how that turns out. So our homework is, again, 20% of the grade, and that score is 75. That gives us a 15 there. Quizzes is still worth 30%, so 0.30 times the 75 score there gives us the 22.5. But then the exam was 50%, and that was the 95 for the student, which adds 47.5 to the grade. So when we add the 15 from the homework, the 22.5 from the quizzes, and the 47.5 from the final, we see that this student got an 85. So compare grades of 3 students. Why do you think the grades differ in the way they do, even though the students have an average of 75 in 2 categories and a 95 in the other? So as we saw, it was because the weights were different. And so the exam was weighted the heaviest, worth the most, however you want to put that. So the student that had the 95 on the exams, since it was weighted the most, got the highest overall average, even though the numbers for those categories were 275s and 195. Okay. Let's look at our final example. Lyle works for a food distributor and needs to determine the current market price for various items. After calling around to several local grain elevators, he compiles the following data sets. Find the mean, median, and mode for each type of crop. And so, again, you'll need to put them in order. And then calculate the mean, the median, and the mode. And I will just give you those numbers instead of going through it. So if you want to pause and calculate them yourself and then check your answers, that I think would be good because we've done enough examples of these. I don't think you need to watch me do all of them. But the mean for our wheat would be $6.31. The median, that middle price would be 6.295, which again, since we're dealing with money, would round to $6.30. And then for the mode, there was no repeaters, so make sure you put none. And for our soybeans, we get the mean. If we add them up and divide by 6, we get $16.33. The median price of the soybeans was $16.30. And then the mode, the most often price, here we had 3 that were 16.30. And then for corn, we had a mean, mean price of $6.67. The median price of corn is $6.76. And the mode for this would be the $6.76 as well. And so it says, based on the calculations from parts A, B, and C, how much should Lyle charge for each? Explain why you chose to use the mean, median, or mode as the price. Well, that is how you would want. I would choose the large or the smallest to be competitive. You want them to buy you from you. I should say that doesn't sound right, but you would want them to purchase from you, so you would want to be competitive with them. And actually, if it was me, I would go penny less than the lowest, because I definitely want business. And so, for example, out of the 3 numbers for corn, I would take the 667 and go lower and make it $6.66. For the soybeans, I would charge maybe $16.29. We don't have a mode for the wheat, but I would charge $6.29. So again, that makes my price the best, and hopefully that means I would have a lot of business. Okay, so those are some examples from mean, median, mode, and range with your statistics. If you have any difficulties, make sure you send me an email, but when you're doing your problems, make sure you're looking for a weighted mean versus the regular mean on the story problems and calculate accordingly. Good luck, and I'll see you next time.